All right, now coming back to this simple cell. So simple cell basically is because there's a chemical reaction, right? Then leading to electricity, right? There is a chemical reaction because the more reactive matter will lose to the less reactive matter. Okay, will lose electrons to less reactive, right? As you lose electrons, the electrons travel in the wire, then it creates current. So in this case, the zinc is the more reactive, right? It will lose electrons, so electron will be flowing this way down to the copper, right? So if you connect a wire, it gives them a pathway for the electron to flow. Then in that sense, you create current. And of course, the greater the difference in the reactivity, the bigger the voltage. So this is a very simple experiment. Maybe I will see it as a kid before. Take an orange, you plug two different metal into the orange, you connect a wire and a bulb, the bulb lights up. Basically, the orange juice is acidic, it acts as an electrolyte, and then you got two different metal, sure it's two different reactivity, then electrons will flow from the more reactive to the less reactive, causing current to flow. Right? It's just a matter of how much the current is produced. Right? So we can see now, be careful is that now the A node, this is a simple cell, there is no battery here, okay? Itself is a battery. So the A node is normally the negative and it's always the more reactive metal. So you see the zinc will lose electron. So we call this the ionized. Okay, then the positive, right, so the electrons flow to the less reactive, right? And of course, it will attract the positive ions. In this case, your electrolyte is sulfuric acid. So basically, you only have H plus as a cation ions. Of course, you got SO4 2 minus and OH minus because of equals. All acids are in equals, right? But cation ions love electrons, so it will be discharged. We form the hydrogen gas, right? And of course, the more reactive the metal, okay, the bigger the difference in reactivity series, the bigger the voltage. And sometimes you will see a reverse sign. That means they put a negative sign. It just means that the electron is flowing opposite. That means now if I say that this is maybe minus one maybe this plus 1.5 volts. Now if I switch, that means if I got zinc here and the copper here, then my reading will be minus 1.5 volts. Because now the electron is flowing from here, from the zinc to the copper, but now it's like left to right. Okay, just now was right to left. So the plus minus do not indicate the voltage. Is it big or small? It's not it's minus 1.5 volt and plus 1.5 volt actually is the same. Just that the electron is traveling in different directions. And of course, in the last chapter of this, you will talk about hydrogen fuel cells. So you don't need to know exactly how the hydrogen fuel cells work. But technically, right, we have hydrogen. Okay, the fuel is a hydrogen itself, right? There's an electrolyte. The electrolyte can be acidic, can be alkaline, and it will go through the reactions like what we learn in electrolysis. And because of the reactions of electron is flowing, the redox reaction, electron is flowing, and in that process, you form your current. So fuel cell basically has two things, right? Fuel means it produces energy, right? Because if you see the equation, it's just a combustion of hydrogen. It gives you energy. And cell means they produce electricity. So basically, this hydrogen fuel cell produce electricity and energy at the same time, right? So normally we see that in rocket fuel, right? So hydrogen, where do we get hydrogen? Okay, do take note. Hydrogen is not present in our air. So it's due to the electrolysis of water, or if you learn organic chem, you learn that it's cracking of hydrocarbon. And of course, oxygen is gotten from the fractional distillation of liquid air, right? Then they get oxygen. Okay, so this is a more environmental friendly because you produce water, right? You don't produce carbon dioxide. Definitely, you have to reduce the carbon footprint, right? But you don't need to exactly know how the things really work. Just be aware. And a lot of times, if the questions wants you to write equations, they will present the data information in the questions to guide you to write the equations. All right. Similarly, anode means oxidized, that's for sure. Cathode means reduced, irregardless of, and of course, in this case, the anode is a negative, right? Because it's a simple cell, and then the cathode is a positive. Is So we need to be aware, are we dealing with an electrolytic cell? That means is there a battery? So there's no battery means it's a simple cell. And the negative and positive, the naming of anode cathode will be opposite. All right. Okay, that's all for electrochemistry. Hope that give you a better understanding. Last but not least, do not forget to go and practice the questions and then look back at this video again to see whether it helps you, especially writing half equations. Again, it's a skill, right? You can only practice, make mistakes, find out where you make the mistakes and learn from it. All right. Hope this has helped you to understand electrochemistry better. See you in the next chapter.